Hi, my name is Valliammai Palaniappan. I'm a PhD student in Electrical and Computer Engineering Department, working as a research assistant in the Center for Smart Sensors and Structures, Western Michigan University. On behalf of my co-authors, I'm presenting our work titled A Porous Microstructured Dielectric Layer-Based Pressure Sensor for Wearable Application as a poster presentation in IEEE FLEPS 2021 virtual conference. Highly sensitive pressure sensors have been receiving major attention in recent years due to its potential application in the field of Internet of Things, healthcare, soft robotics, human-machine interface, tactile and touch sensing application. Different transduction mechanisms of pressure sensors such as piezoelectric, piezoresistive, and capacitive have been reported. Among these mechanisms, capacitive-based pressure sensors in particular have advantages such as low power consumption, repeatable response, and independent of temperature and humidity variations. In this work, a novel porous microstructured dielectric layer was fabricated to achieve high sensitivity for wide pressure range. Porous structures in PDMS was achieved using acid-based chemical reaction method, and microstructures were created using laser engraved master mold. The fabrication details and the performance of the capacitive pressure sensor is presented in this paper. The porous PDMS mixture preparation is depicted as shown in this figure. It was prepared by mixing 10:1 PDMS sodium hydrogen bicarbonate nitric acid, and it is implemented as a dielectric layer in this paper. Microstructure patterns was designed using AutoCAD and then imported to the laser machine. Initially, a CO2 laser beam with 10.6 micrometer wavelength, 15% power, and 5% speed were used to engrave the acrylic sheet-based master mold as shown in this schematic. The square patterns were engraved using the carbon dioxide laser source. The prepared porous PDMS mixture was then poured onto the engraved acrylic mold and thermally cured for 30 minutes at 40 degrees Celsius, as shown in this schematic. After curing, the porous microstructure layer was peeled off from the acrylic master mold. Photographs of the fabricated PMS dielectric layer is shown in this first figure. The top view shows both the porous pattern as well as the laser engraved square patterns. And this picture shows the side view of the fabricated dielectric layer, and this picture shows the PMS PDMS pressure sensor with the fabric electrodes. For the experiment setup, the fabricated pressure sensor was mounted between the two stages of the Mark 10 force gauge system, and the two terminals of the pressure sensor were connected to the precision LCR meter, and the precision LCR meter was connected through the GPIB cable with the PC with LabVIEW system. The first figure shows the dynamic pressure range of the pressure sensor. The capacitance of the pressure sensor was increased from 5.22 picofarad, which is the base capacitance, all the way up to 5.47 picofarad when the pressure was increased from 0 Pascal to 1 kilopascal. Similarly, a capacitance was increased from 5.47 picofarad to 6.64 picofarad when the pressure applied was increased from 1 kilopascal to 10 kilopascal. The second figure shows the relative capacitance change of the pressure sensor. A sensitivity of 4.98% kilopascal inverse with a correlation coefficient of 0.97 was obtained for the first pressure range, ranging from 0 to 1 kilopascal, and a sensitivity of 2.53% kilopascal inverse was obtained with the correlation coefficient of 0.99 for the second pressure range, ranging from 1 kilopascal to 10 kilopascal. The third figure shows the stepwise pressure response of the pressure sensor. The hysteresis response of the fabricated pressure sensor was measured by applying stepwise pressure increasing from 1 to 10 kilopascal, which is the loading pressure, and decreasing from 10 to 1 kilopascal, which is the unloading pressure. The hysteresis response was calculated from the stepwise pressure response. A maximum hysteresis response of 2.8% was calculated for the applied pressure of 4 kilopascal, and the overall degree of hysteresis for the fabricated pressure sensor was measured to be 1.4%. In conclusion, the porous micro-square structured PDMS dielectric layer was successfully fabricated using acid-based chemical reaction and laser engraving technique. A sensitivity of 4.98% kilopascal inverse was obtained for 0 to 1 kilopascal and 2.53% kilopascal inverse for 1 kilopascal to 10 kilopascal pressure range. The sensor also exhibited an average hysteresis of 1.4%, indicating a high elasticity characteristics. Future work will include additional results of comparison between the relative capacitance change repeatability and hysteresis response of the microsquare structure without porous pattern with the PMS pressure sensor with porous pattern. Thank you.